Hello guys, here we are again back with the same topic, that is powers and exponent. In the previous video we have seen what is power and exponent, how to find the particular power format or exponential format for any particular number, how we can denote the exponent and base. These all basic concepts we have seen into the part 1. Now this is the part 2, in which we will see what are the laws of exponent, that using which law we can easily simplify any big sum. Okay, so let's just start with the laws of exponent. Now, the first law of exponent is that if I'm having the same base, okay. Now, in the previous video, we have seen the number, this a will be calling as a base, and the power which is raised to it, that we will call this as an exponent. Okay, so if I'm having, now this first law depends on the base. If I'm having the same base, okay, let's just have a raised to m and a raised to n. Okay, first power is m, second power is n. But if my bases are exactly same, then my powers will, or the exponents will get added with each other. Okay, let's just have one example for this, that how this law works. Now this is 2 raised to 2 multiplied by 2 raised to 5. Okay, so according to this rule, what it will happen, it should be 2 raised to 2 plus 5, and that is will give me 2 raised to 7. Okay, but what is the idea behind it, that I will tell you. Now, what is the meaning of 2 raised to 2? That 2 times my 2 multiply with each other. And what is the meaning of 2 raised to 5? That 5 times my 2 will multiply with each other. This is nothing but 5 times. Okay, now how many total 2 are coming here? How many times it is there? That is 1, 2, 3, 4, 5, 6 and 7. Total 7 times my 2 is there. So I can write 2 raised to 7. So this is what the idea behind my first law. Okay. Now let's just have my second law, that is a raised to m divided by a raised to n, which is nothing but equal to, it results out into the subtraction of exponent. Okay. The rule is same, that whenever my bases are same, okay, and if that power comes with a division, then my exponents subtract each other. In multiplication, exponent adds itself. In division, exponents subtract itself. Okay, let's just have an example, that is 5 raised to 2 divided by 5 raised to, just take it as a 5 raised to 12 divided by 5 raised to 7. Okay, now 5 raised to 12 is divided by 5 raised to 7. According to the rule, what it should be? It should be subtraction. That is 5 raised to 12 minus 7. That will give me 5 raised to 5. Okay, but what is the idea behind that rule? Now 5 raised to 12 divided by 5 raised to 7. I can write this exponent in the, I can write this power into the form of fraction also. Now 5 raised to 12 means how many 5 is multiplied here? 5 is multiplied here 12 times. How many times my 5 will multiply here? 12 times. Divided by 5 raised to 7 means what? How many times my 5 will multiply here? That is 7 times. Right? So 5 multiplied by 5, that is 12 times, and 5 multiplied by 5, that is 7 times. So what will happen? These both are now in division. These both are now in division. So what it will take place? It will take place cutting, right? We know how to cut it, how to do the cutting of it. Divided by 5 multiplied 7 times. 3, 4, 5, 6 and 7. Okay, now we can perform the cutting. That is 5 ones are 5, 5 ones are 5, 5 ones are 5, 5 ones are 5. Like this we can do the cutting. Okay, now how many 5s are remaining, that we will count. 1, 2, 3, 4 and 5 times my 5 are remaining. So I can write it as 5 raised to 5. Right? See, this answer and this answer are exactly same. So the reason behind, or the logic behind this second law is this. Okay, if this is 12 times my 7 is coming, from that 7 times my 5, if 12 times my 5 is coming, from that 7 times my 5 will get cancelled out with each other. So how many times 5 is remaining? That is only 5 times it will remain. And this is what we are doing, the subtraction of an exponent. Okay, so now let's just have my third law, that is the zero exponent law. Okay, if my base is having a 0 as an exponent, then the value of that is always a 0. Okay, the value of it is always a 1. For example, if I say 2 raised to 0, then the value is always a 1. Base can be anything. It may be 100 also, but still your value will be 1. Okay. Now we can have the logic behind this law. That is, if I'm having 2 raised to 5 divided by 2 raised to 5. Okay. Now, according to the second law, if my bases are same, my exponent will get subtracted each other, right? So this is nothing but 2 raised to 5 minus 5. That is nothing but 2 raised to 0. But I can write this division into this format also, and 2 raised to 5 will be same, 2 raised to 5 will be also same. Both are nothing but 32 only. So if 32 will get cancelled, what is remain with me? That is 1. And we know in the mathematics for a particular question, there will be only one and only one possible answer. Though the steps can be anything, but the answer will not get changed. And from that we can say 2 raised to 0 is exactly equal to 2 raised to 1. Okay, so this is what the logic behind my third law. Now let's just have the fourth law. That is nothing but if any number is given to me, then I can write that particular number into the form of exponent by giving 1 as a exponent. Okay, we have seen exponent is what? Exponent shows that how many times your particular number is repeated. Okay, if I have to show 5 into the exponential form, what it will be? Now, how many times 5 is here? Only 1 time. So I can write 5 raised to 1. Okay, so in this way I can write any number by giving exponent 1. Okay, let's just move to the fifth law. That is nothing but same exponent law. If I'm having a raised to m multiplied by b raised to m, then I can have taken that exponent common. I can take the exponent common. How? Let's just have the logic behind it. If I'm having 2 raised to 4 multiplied by 5 raised to 4, then I can write 2 multiplied by 5 raised to 4. That is nothing but 10 raised to 4. Okay. According to the E law, I can write that. Let's just have the logic behind it. 2 raised to 4 is what? That is 4 times I am multiplying 2. Okay. And 5 raised to 4 is what? That 5 times my 5 will come. 5 raised to 4 means 4 times my 5 will come. So I can arrange this into this format also. 1 2 1 5. Like alternate arrangement I can make. Okay. Now what it will be? 10 multiplied by 10 multiplied by 10 multiplied by 10. Right? 4 times 10 is there. So this is nothing but 10 raised to 4. Right? So according to the rule also I'm getting same answer, and by traditional method, okay, without using law also I'm getting the same answer. Okay. So by using this law we can have this so we can satisfy using this example. And the last law, that is nothing but if I'm having the same powers in the division. Okay, first rule was same exponent in multiplication, and then same exponent in the division also, then also I can take it out common. I can write this law in the form of fraction also, because fraction is also one form of division only. That if I am having a raised to m divided by b raised to m, then I can take the power, then I can take the exponent common as a upon b raised to m. Okay, let's just have one, that is 2 raised to 5 divided by 7 raised to 5. Okay, I can write this as 2 raised to 5 upon 7 raised to 5. Okay, now 2 raised to 5 means how many times my 5 is coming? My 5 is coming 2. Sorry, my 2 is coming 5 times. 7 raised to 5, that is also means that 5 times I have to write 7. I can write this into form of 2 by 7 multiplied by 2 by 7 multiplied by 2 by 7 5 times. Right? So from this what I can conclude? That I can conclude that 2 by 7, this rational I am multiplying with 5 times, so I can write 2 by 7 5 times. So from this step we can reach to this step, and this is how we have proved that if my exponents are same, then that exponent I can take it out as a common in multiplication as well as in division. So these are the basic rules which we have studied today. Okay, now there are some rules are there with a negative exponent also. Okay, these are the laws in which our exponent was positive. Now we are having some laws also with the negative exponent also. That laws we will study into the next video. Thank you.